today we're going to be working on Chapter 3 proofs. So yes, they're coming up again. You're going to prove properties of parallel lines and transversals. So along with all your other reasons from Chapter 2, you will also be including all of your reasons for Chapter 3. So notice that we have your alternate interior angles congruent, corresponding angles, same side interiors, alternate exterior angles, and same side exterior angles. We also have what you did yesterday. So these reasons are a little longer than the other ones you've been used to. But these are, if two lines are parallel to the same line, then they're parallel to each other. Two lines perpendicular to the same line, then they're parallel to each other. If one line is perpendicular to one of two parallel lines, it's also perpendicular to the other line. So a little trick with the first one, you want to look for two parallels in a row in your proof, and your reason, where you put this reason, is at the third. For the second one, you want to look for two perpendiculars in a row, and you're going to put this reason after you see parallel. And this one, you see a perpendicular and a parallel, and you write it at the perpendicular part. So I'll show you what I mean when we get to those proofs. Okay. So this first proof, just like your ones in Chapter 2, you want to highlight your givens and write those in right away. So your given is A is parallel to B. What a surprise, it's the first one. Then what helps me is doing the shade for the rest of the proof. So what I see now, and what's going to be a little bit new for this chapter, is that we see this parallel, okay, and then we're told that angles are congruent, okay. When you see that parallel first and then congruent, you're going to be using this set of reasons. Notice all the parallels are first. That's how this one's going to be. So you know you're going to write parallel then. Now for 1 and 4, this is when you have to look at the picture. So if I look at the picture and I see 1 and 4, so if I were to mark that there, I need to decide what kind of angles those are. So that's what we did at the beginning of the chapter, where you had to decide if they're corresponding, alternate interior, alternate exterior, same side interior, same side exterior. They're also listed at the top of your note sheet. Here we have 1 and 4 are in corresponding positions. So I'm going to use that reason that I just circled, parallel then corresponding angles congruent. All right, so now we're on number 3. So 4 and 3, I already used up the fact that A and B is parallel, so I can't use that anymore. But I do see in the picture that 3 and 4 are vertical angles. So this reason is vertical angle theorem, or vertical angles are congruent. Number 4, notice that we have 1, 2, 3. So this is a pattern we've seen in proofs before. We have 1 is congruent to 4, 4 is congruent to 3, 1 is congruent to 3. Notice that those 4s in steps 2 and 3 match. This is the transitive property of congruence. Next proof, same deal. Highlight your givens, first thing. So I have 2, yes. So I have number 1, and then we're seeing number 3. Given, sweet. I have those done already. So now what's going to help is I'm going to use my shade here. Just like that last one, we have parallel, then supplementary. Okay, so I know my next reason is going to start with parallel then, just like how it did in the statements. But now I gotta figure out what is the relationship between angle 3 and 2, so that's where I have to look at the picture. So if A and B, where's A? Here's A and B are parallel, then 2 and 3 are supplementary. So 2 and 3. So again, I'm looking at this set of reasons because they all have parallel first. And the ones with supplementary are only these two, so that narrows it down. Now I just have to decide if those are interior or exterior angles. So 2 and 3 are on the same side, and they're both in between the two parallel lines. So this is parallel then, same side, interior angles, supplementary. Right. Now we gotta go, oh look, another, so we have given, and then we have another parallel. So that's that same deal, so I can do this again. So I have parallel supplementary, so then I go parallel, then, now I just have to look at 1 and 2 now. I need to erase this so I can look at this better. Okay, so if we have C and D, here's C, here's D, and 1 and 2 are touching line A, so I'm gonna look at this one. So now with these two parallels, 1 and 2, are also same side interior angle. So I use the same reason and the same proof, which is fine. That happens. Same side, interior angle, supplementary. Great. Now number 5 is one we have not used yet in a proof actually. Here, what you're going to use for number 5, okay, is I have angle 3 is supplementary to 2. And 1 is supplementary to 2. Then 1 and 3 are congruent. So notice 3 and 1 are supplementary to the same angle. So now they're congruent. This is the congruent supplement theorem. Congruent supplement theorem. So that's one we haven't seen yet. Great. Next proof, givens. First, actually just one given. So write that in first. Okay, I'm gonna get my shade. All right. This next reason should be written in on your notes. If it's not, right angle addition postulate. That one would be given to you on a test. This is talking about how 2 and 3 are a linear pair. So you don't need to do that on a test. That will be written in for you. That's probably a mistake on my part. All right, so now let's look at step 3. Well, I haven't used the parallel part yet. So I have parallel, then congruent. So I know this is going to be parallel, then something. So now I just have to look, okay, here's A and B are parallel, and they're talking about 1 and 2. So 1 and 2, so I have to decide what kind of angles those are. Those are corresponding, so I'm going to write corresponding angles congruent. Next one's done for me, this is awesome. I have to, for number 5, now I gotta really think about this here. So, I look throughout the proof, it kind of looks like number 2, because it's still got the 3, the 180s, but they replaced the 2 with the 1, and that's because 1 and 2 are the same. So what they did is they substituted. More of this, and then we have 180. So in this one, we have 180, these angles adding up to 180, then they're supplementary. Vocab. So this one is definition of supplementary angles. What you've seen before is supplementary first, then them adding to 180. The definition goes both ways. You can say they add up to 180, then they're supplementary, or you could say they're supplementary, then they add up to 180. So you can see them switch to improve. All right, next one. Please write for step 2 if it's not already. Right angle addition postulate. That should already be there. You won't have to write that in. All right, so now let's do givens. How many do we have? 1. Given. All right, there's my shade. Go. All right, so we're given, it's 180. I mean, I'm not doing any parallel stuff yet because I didn't see the parallel symbol. So I can't do any of that. So now when I look at step 3, I have to look what I have previously. So I have 1 and 3 is right here. Then we have 1 and 2 over here. So it looks like instead of writing 180 in step 1, they wrote the 1 plus 2. So this one is substitution. All right, step 4. We have 3 and 2. So it looks like from 3 to 4, they took away the measure of angle 1. So another way to do that is subtraction. Property of equality. Number 5, that will always be written in for you. Definition of congruent angles. You'll never write that. All right, now here's a new one. Okay. Here we have congruent to parallel. So on the other ones, we had parallel first and then congruent or supplementary. Like if you look at this slide again, we had parallel, then supplementary. On this one, we have congruent then parallel. So I'm going to be looking at these reasons. So if I see parallel last, parallel is going to go last. So when I look at my picture, if I see on N, and then 3 and 2, I have to decide what kind of angles those are. Those are corresponding. So corresponding angles. All right, next, back page. First do your givens. So 2, that's good. You write those in right away. Do my little shade. All right, here we go again. You see parallel, then congruent. So now I'm going to use this set. I know parallel is going to go first. Now I just have to decide what kind of angles 4 and 8 are. Oh boy, this is like a big picture. So where's L and N? Here's L and N. And 4 and 8. Where's 4 and 8? Right here. So I'm going to highlight K so it's easier for me to see. They're saying 4 and 8 are congruent. Those are corresponding. Corresponding angles congruent. Okay. Then 3 was given. Sweet. Now I have, look, 3 congruents in a row. I have that diagonal going on, this transitive. Transitive property of congruence, and then 5. All right, now we have both of them in the same proof. We have congruent to parallel. So that means I'm going to use this set of reasons because parallels last. So I got to put the little parallel lines at the end and decide where 4 and 12 are. I'm going to erase this. All right, so I have J, K. Here's J, here's K. 4 and 12 are right here. So 4 and 12 corresponding again. Corresponding. Okay. All right, so this next proof is going to use our new reasons. We have, well, I have to read givens first. Like, oh, it seems like a lot. So we have these two, and C and D is in step 3. Well, I only need to do 2 of them, so that's nice. Given, okay. Let's see here. Okay, so we're seeing we have 2 perpendiculars, then A is parallel to C. Okay, so we have A and B are perpendicular, and then B and C are perpendicular, so there you go. Now they're saying A and C are parallel. Okay, so if these ones, if you see how the second one has those 2 perpendiculars, 2 lines perpendicular to the same line, they're both perpendicular to B, then they're parallel to each other. That's exactly what that one said. So now you just have to write really slow and write that whole thing in there. So 2 lines perpendicular to the same line, then parallel to each other. Yeah, I know that one's a long one. Right, the next one's given. And then here, this is almost like the transitive property, to be honest. Like, it looks like it, but there's no transitive property of parallel. Like, do you see how they match like that? This one is actually that first one. If 2 lines are parallel to the same line, then they're parallel to each other. So you're saying A and C are parallel, C and D are parallel, and then A and D are parallel. Okay. So if they're parallel to the same line, then they're parallel to each other. So write that one again. 2 lines parallel to the same line, then parallel to each other. Ooh, that's a long one. That's all right though. We're going to do givens. So we have number 1, number 5, I'm going to find B and C. Given. Okay. All right. So here we have perpendicular to right angle. This is a chapter 2 reason. If they're perpendicular, then it's a right angle. That's the definition. All perpendicular lines. Now we have right angle to 90. Definition of a right angle. Given, sweet. Parallel, that's what we're doing today. Parallel to congruent. So I know I gotta go parallel first. Now I gotta look at the picture. Where's 1 and 2? All right, so B and C. Then they're saying these are congruent. Those are corresponding angles. That ones are filled in. Now 2 and 90. Well, I didn't see right angle yet, so I can't do anything with definition, because that's usually a common mistake. Let's look where 90 is again. Here we have it in 3. Have them equal. Well, it looks like they substituted. So in step 3, they substituted the measure of angle 2 and for measure of angle 1. So this is going to be substitution. And then, now I can say definition, because I have 90 to right angle. See the word, definition of right angle. Oh, got one more. Okay, now I have right angle to perpendicular. This is definition perpendicular lines. All right, last proof. Givens. Just one. Given, put my shade. All right, so here we go again. We have the parallel, then congruent, so I know it's going to start parallel then, but now I got to look at the picture here. So here's A, here's B, 1 and 3. So 1 and 3. It's our corresponding. A lot of those today, holy cow. All right, now we have step 4. This one should be written in for you. Sorry, I said at the beginning. This is angle addition postulate. That's talking about how 2 and 3 are a linear pair. You won't write that in on a test. Okay. Now from 4 to 5. What changed? It's almost the same. Because they still have 2, they still have the 180. This changed because they're equal. So that's substitution. And what do we have? 180 to supplementary. Vocab. So they add up to 180, then they're supplementary. That's definition of supplementary angles. All right. So there you go. Have a good night.